Welcome to Marine Tech Talk, a podcast about how Teledyne Marine's innovative technologies are enabling scientific discoveries and commercial tasks in the world's oceans and waterways. On this episode of the podcast, we meet Tobias Haswell, a program manager for Diakont. Tobias's program provides robotic solutions for use inside of nuclear power plants. The program's primary work involves using submersible ROVs to remove contamination from within reactor cavity pools, as well as other pools within the nuclear power plants. Tobias has been involved with providing robotic solutions to the gas, oil, and nuclear industries for more than 7 years. Here's Tobias Haswell with the host of Marine Tech Talk, Melissa Rossi.
Tobias, just to start off, could you tell us a little bit about Diakont, what they do, and then what you do for them?
Sure. We work with a lot of robotics, not just in the nuclear, which is what I work in, nuclear field, but we work with oil and gas. They have a series of crawlers that they use to do UT inspections and non-destructive testing inspections inside pipes, inside of tanks, and they'll be able to put them down. They have MFL, different tools for that. They also deal with actuators. They have a whole series in the nuclear side that I haven't personally specialized in. Everything from cameras to, I think they have a few different robots that are for welding and other nuclear related activities where you don't want to put humans. So this is our newest robot, and it goes inside of the reactor cavity pools. It's one of the spots that's the most contaminated areas that you're going to have to deal with, and it goes in there and it's able to help clean and prevent other humans from going and getting contaminated and picking up radioactive dose and things like that.
That's pretty cool. So could you tell us a little bit, or tell me a little bit about how the process works? So from the time that you get the job, what do you have to do to prep for the job? And then of course the Seabotics ROV, what do you need to do there? And what is that ROV doing for you there?
So let's see. So we get the job. There's scheduling and coordinating with the customer. And they have quite a lot they're doing. I mean, this is a nuclear power plant, and I guess I should say the background on nuclear power plants, because some of your listeners may not know what a power plant really does or how it works, right?
I'm sure a lot of them don't. I don't.
Okay. So it's really simple if you break it down. It's just like a lot of other power stations, and they're going to use heat to turn water into steam, and then the steam is going to turn a turbine, and that's going to use a generator to create electricity. So that's the same for coal. It's going to be the same for nuclear. It's just what the fuel is that's different. So instead of coal and burning that, you're going to have some nuclear fuel, and it's going to be having the atoms will be splitting, releasing energy, and that energy is going to heat the water, turn it to steam. So it's pretty basic at that level. But so every so often, the fuel that they use, they're going to have to reshuffle it around, reposition it so that it stays efficient. They might take some of the old fuel out, put new fuel in. When they do that, they need to have their employees that are working and moving this fuel to actually be protected from the radiation. So what they'll do is they'll flood up the area. It's in this giant cavity, and they'll flood the whole cavity with water. And that water is going to act as a shielding for the employees that are using machines to pick up the fuel and move it around and so reposition it. So they flood this cavity with water. Now, when they flood the cavity with water, that water is touching the fuel, the radioactive fuel, and it's getting contaminated. And then when they need to reassemble the cavity and to close the fuel up after they've finished, they're going to have to drain down all the water out of the pools. They're going to bring all the water, empty it out, and you'll have contamination left over, though, on the walls and the floor and all the surfaces inside of that cavity. And then they're going to need to send people down to reassemble it, to physically bolt it back together. But they're going to be surrounded by this contamination, and this contamination is giving off radiation. And they're being exposed to this. Now, they're going to send down a group of people to first check the radiation levels, and depending on how bad they are, they're going to then send another crew down, and they're going to clean and try and lower the levels. And then they're finally going to send down the crew that's going to actually reassemble everything and do all the other work that they need to get done when they're down in the cavity. What the robot's going to do now is the robot's actually going to be put in back when all the water is still in the cavity before people have to go down there. And the water's contaminated and it's filled up the cavity. We're going to put the robot in. Now, the robot's going to go around and start cleaning all those surfaces before the water gets drained. So it's going to clean the floors, it's going to clean the walls, and it's going to use its brush to knock all the contamination off the surfaces, get sucked up, and it's going to go to a filter before being recirculated back in, and it'll be clean water at that time. Then when the drain down happens, the contamination levels are going to be much, much lower. You're going to be able to send people down. They may spend half the amount of time doing the actual cleaning. They're going to get exposed to maybe half the amount of radiation just off the get-go. Those are going to be the people that are actually cleaning it. It's going to save tons of dose, which is the amount of radiation they're receiving, as well as time, which is money to the plant. So that's the greatest benefit, is it's going to be much safer and much more cost efficient to the plant and to the employees that are working there.
How long do you have to do this process? How long do they shut down for?
It depends on the plant. So some plants are going to be longer than others. I think I just got done with one plant that typically does somewhere from, say, 17 days, which is really fast, really short. I think the record they've had is 17 or 15, depending who you ask. I just talked to another plant. They do theirs in about 28 days. So it could even get up into 30-something days.
So how long does your actual cleaning take with the robot? Out of those, is it the full 20 days or no?
No. We'll actually only spend maybe 3 or 4 days in the water. And that's right at the end, right before the water is going to be drained down. So we're just at the back end of the whole thing when they're almost finished.
Okay. What was the plant doing before you had the robots? So how did you clean the facility before you had the robots?
Sure. They would go down with a pole and a brush.
They being an actual person.
An actual person, yeah. Well, so there are a bunch of different ways, I should say. Wouldn't just be a pole and a brush. That's one version. Someone goes down there and they've got a Scotch-Brite pad or some other rough pad attached to the end of a stick, effectively, and they start scrubbing the walls, scrubbing the floor, trying to get all this contamination off for cleaning. Other methods they use is they might spray it with water, high pressure spray, trying to knock it down. But in the end, a human's going to have to go down there and most likely do some sort of manual scrubbing by hand.
Can you actually see this stuff?
No,
okay.
Not at all.
So you're scrubbing a wall and you don't know if
Yeah.
you've actually cleaned it.
Oh, the wall looks shiny. You can probably see a reflection. It's stainless steel. Wow. So you can see, not a perfect reflection, but you can at least see a reflection. You don't know if you're clean or not. It might look perfect and be very contaminated, very radioactive, or have a high radiation source. So it might be very contaminated, or it might even have some dirt on it and not have any contamination. So just because you can see something on there doesn't mean you have contamination.
So do you have to monitor that while you're scrubbing? Is there some way you can tell whether it's there, you've gotten it off, or is it just the scrubbing process and then they do something afterwards?
Sure, they have different tools and instruments where they can actually read how much radiation is in that area. And then that's sort of how they're able to guess if they've been making an improvement. They also have ways where they can wipe the surface, and then they'll go measure the wipe. They call it a smear. They'll go measure that and see if there's a certain level of contamination on that.
Okay, that's kind of like when they wipe your suitcase when you're at the airport or your computer to see if there's any explosive material, I presume, but something.
That's right? Exactly, yeah. But they're checking for contamination instead.
Right, interesting. So on the ROVs, you are using a specially designed cleaner, so it's not something that we provide, but you do. How did that all get started? How did that technology get started?
Sure. So we had a nuclear power plant, First Energy, out in Ohio, and they came to us and they said, hey, we have a need for this, and can you help develop a robot to do this, to take it away from humans doing it as much? So the great thing is we're not actually replacing jobs in this case. We're just helping others to do their job. That's just one of those things I love about this. But so that's how it got started. Is they came, they approached us, and they said, can you help build this robot? Help us out here. And we said, yeah, well, we'd love to. And we looked at Subotics, and they already had a tool that's designed to have other tools attached to it. So they already have a robot that has multiple tools that can be attached. And the challenge was just, what tool can we build and then incorporate with the existing system? So we took the crawler base that allows the ROV to suction onto walls. And we took the VLBV 300, which is a crawler that has about 4 thrusters, so it moves around underwater just like you'd see a drone in the air. Okay. So it can slide side to side, it can rotate, and it can go up and down. And then when it gets close to a wall or another surface, it can use an impeller vortex generator underneath the crawler to suction onto that surface. So let's say you're going to attach to a wall. The robot slides its side right up against the wall, and then rolls to the side so that its bottom is now facing the wall, and it suctions on. Once it's suctioned on, it can drive around just like a tank would because it has treads on either side. And then that's when our tool, the attachment piece, comes into play. So while it's driving around, we have on the front of the robot, we've attached a brush that's able to scrub the surface. And then around the brush, we've put a shroud, and that helps so that any debris that gets kicked up gets contained within the shroud and then gets sucked through a hose to a pump filter vacuum system.
So it really is just like a big vacuum.
It is.
That's
just
right
a big
on the
vacuum.
front of the robot.
Yep. I'm a glorified cleaner.
So was that developed by the engineers at Diakont?
Yes, the cleaning tool attachment was developed by the engineers at Diacon, and then obviously working very closely with some of the engineers at Subotics so that they could incorporate some of the programming, communication, and figuring out how we're going to get the right power sources. I think we also used the motor that drives the brush is just right off of Subotics' main line of other motors so that it's a perfect communication.
Oh, that's great. So how long have you been doing this with the robots?
Well, the first job was in 2017, and I believe we did 2 jobs that year. We did another job in 2018, and this year we did 5 jobs. So it sort of skyrocketed this year, and we have quite a lot planned for next year. So it's really taking off. A lot of new power plants that are interested in getting into this, as well as some of the ones we've done have already been asking us back for the next year.
Okay. So you're bringing in the ROV, it's going into a contaminated environment. I would imagine that you can't just grab the ROV, throw it back in your van, and head back home again, right? So what happens then?
Yeah, so it comes out of the water. It's now been in contaminated water. So obviously there's contamination on the robot itself. And yes, you're right. You can't just take it back to the office to work on it. So they have hot shops and special areas where you can work on contaminated equipment. We tend to do most of our work at the power plant. We'll decontaminate it ourselves, which is a lower dose than maybe if you were to have gone into the pool itself. So you decontaminate this robot, get it down to a acceptable level, whatever you want that to be. But in this case, it's usually 50K for us, which probably means nothing to listeners, but just accept that that's a very low contamination level. And then we can store it and send it to the next plant. So these tools go from one plant to the next plant, and they never really return home. So we've had to learn how to fix them, repair them in the field. Yes, that was a learning process, not being able to bring it back to an office, bring it back to a workshop per se.
So if you're working for a customer and you use the vehicle there, does it stay with the customer, or does that vehicle then have to go to the next job site and it stays there waiting for the next job?
Right. So when we finish it with one customer, we might be sending it to one of their sister plants. And so after we've packed it, it'll get shipped to the next one. Maybe it's a totally different customer, and so it still gets shipped to that plant next. But it just goes from one to the next.
How does the ROV benefit the customer?
Yeah, there's a financial savings. Obviously, that tends to drive a lot of companies.
It usually does.
Yeah. So not always. It depends again who you ask, but the cost that a plant might expect to see for during the outage, what it might cost them, is maybe $500,000 a day. The cost that they're going to see from potential earnings, and also the cost that they're going to have lost from having to pay for all the activities that are happening during the outage, could exceed $500,000 a day. Okay. So when we're saving them a few hours, that's obviously adding up to a financial savings for them. I think on this last job we did, we ended up saving them 4 hours of critical path, which obviously translates directly
to money, right?
Yeah.
Sure.
Additionally, they have certain goals they're trying to reach with their employees, trying to get them exposed to less radiation. So that's a benefit also. Now the robot's being exposed instead of the people.
Right. What is the time savings? You mentioned just to save them a few hours. Is that typically the difference between doing it by hand and doing it with the robots? Is it a few hours difference, or is it more than that?
Sometimes it can be more than that. We've had one customer where they had to do no manual decon afterwards. So they were able to drain down and go straight into reassembly. So that was a big savings for them.
Are most of your customers here in the U.S.?
Yes, we have yet to do any decon robotic services outside the U.S.
Is that something you're looking at now?
Well, maybe. I wouldn't turn it down.
Great. And is this something that you see on the rise in general? Is this fairly new for the industry to be able to decontaminate these pools with robots?
Yeah, there have been people doing it before us. I don't think, we're not the first to give it a shot, but I'd say we're the best.
Okay, that's fair enough. Maybe the most successful doing it. That's great. Are there any other applications that you can think of that these robots, or the Seabotics robots, could be used for in a nuclear facility? Or is this really the primary application?
That's the primary one that we've been, but we've also had them reach out to us for doing some NDT inspections. Using robots in nuclear power plants isn't brand new. They've been using them for visual inspections before. They've been using them for other types of NDT. I mean, visual falls under that. But UT, things like that. So we've had some of them reaching out to do ultrasonic testing, which is what UT is. We've had them reach out to us to do that for some other areas in their plant, as well as visual.
And are those wet areas, or are they dry typically?
These would all be wet for the robot, for the ROV.
Because Teledyne Seabotics does make a UT sensor, so that's interesting.
Yeah, we've been looking at that.
Oh, good. Anything else you think that the listeners might find really interesting about what you're doing? Are you expanding your program at this point?
It's like I said, we jumped to 5 jobs this year, so that sort of exploded from previous years, and I don't see it slowing down. I think it's going to continue increasing, and we're going to get a lot of customers that want to make this into a standard procedure that they do. It's not going to be a new thing anymore. It's just going to be industry-wide. When you do a drain down, you decontaminate with a robot. I think we're moving away from exposing humans to that risk.
Well, that sounds like the perfect direction to move in. I can't imagine that people would want to go into an environment like that. Obviously, it's part of their job now, but if they could avoid it, I would think that would be the best, right? So good for that's really a great development and a good use of robotic technology. So it's good to hear. Thank you so much for joining us.
Thank you.
Appreciate it.
Thanks for listening to the Marine Tech Talk podcast. To learn more about Diakont and the work that Tobias and his team are doing in nuclear power plants, you can visit diakont.com/nuclear_solutions. You can also follow them on Twitter by following @Diakont. If you have any comments or questions about this show, you can email host Melissa Rossi at marinetechtalk@teledyne.com. If you like this podcast, please make sure to subscribe on Apple Podcasts or wherever you're hearing this show. That way, you'll never miss an episode. Thanks for listening, and we'll see you again next time.